Stuff that I don't really understand.
What is it?
So this is something that I just learned today. But here, I'll read the problem note for you. It's f of x equals
Go ahead.
2x minus 1 over 2 minus x.
Okay. They want you to graph it and label all vertical asymptotes, horizontal asymptotes.
No, they just want to find the answer, I don't think. I don't think we need to do any of that.
There's no answer. That's not any... In other words, what you have here is a function. Now, if you tell me that that's equal to some number, I can tell you what x is equal to.
No, wait. I think we just... Hold on.
Can you take a picture? Can you take a picture of the book or review material that you're getting this problem from and send it to me?
Yeah, I have some work on it already because we were doing it in class.
That's okay. But at least it would clear up any discrepancies like this. Because at this point, this is not a problem. There's nothing you can do with this.
Okay.
It's got to be equal to something, or...
I think there's an x version and a y version. Is that what you mean?
Well, you could take the inverse of this function, if that's what you're talking about.
Yeah, actually, that is it. Find the inverse of each of the following functions.
Fine. That's what I needed to know. Finding the inverse is actually fairly straightforward. Okay? First of all, switch the variables and then solve for f of x. And in fact, I prefer it if we turn f of x into y right away, like that. And that's legit. You can do that. You with me?
Yeah.
Now, switch the variables and solve for y, and you'll have the inverse. So, if I switch the variables, what do I have?
If you switch the variables, then it's going to be... wait, like switching all the x's to y's?
Yep, and all the y's to x's.
Would you move some of the say the bottom one?
Whenever you see a y, make it x, and whenever you see an x, make it y.
Okay.
What do you get?
So it would be y equals 2y minus 1.
Whenever you see a y...
Or no, would it be x equals 2y minus 1 over 2 minus y.
Now, the problem is solve for y. Once you solve for y, you'll have the answer. Okay? Now...
Wait, I have a question.
Huh?
I have a question.
Yep, go ahead.
So, I have, well, actually, I just want to go over this question because I didn't quite understand, like, how to go through it. Like, I have the answer, but I just didn't understand how to go through it all. But when I'm looking at the answer, is it, just the complete opposite of the,
no,
like...
not quite, but close. Not, you can't really say it's the opposite. It's the inverse. The inverse, by definition, undoes what the original function did. If I have an original function of y equal x squared, well then y inverse is square root of x.
Okay.
Okay? That's what inverse means, is it's the function that undoes the original function. So it's not really fair to call it the opposite. Let's solve this, and then you'll see. If we go through one, I think it'll become a little clearer. So how do I solve for y? In other words, this now becomes just an algebra problem.
What you do is you multiply both sides by 2 minus y.
Okay, so that gives me 2x minus xy on the left. Gives me 2y minus 1 on the right. Now what?
And then after that, then you can move the 1 over to the other side.
Okay, and do what else? What's the goal here at this point?
Basically to get y alone.
Yes. So, okay, so I'm going to move the xy to the right, and I'm going to move the 1 to the left. That's fine. That keeps everything nice and positive. But what I'm really doing is any term that has y in it, I'm moving to the right. Any term that doesn't have y in it, I'm moving to the left.
Yeah, okay.
Okay. Now, that's a key step because now I can factor out a y. In other words, the right, there's always going to be a common factor that I can take out. That's it. That's
and then it's
2x plus 1. Now if you solve for y, it's dividing both sides by this 2 plus x. So we get 2x plus 1 over 2 plus x. That is y inverse. It's not really fair to call it y. It's not y. Y was 2x minus 1 over 2 minus x. This is 2x plus 1 over 2 plus x.
And the reason why I was asking about the opposite thing is because, exactly, it has the 2x plus
it looks
1.
It looks like it's just the opposite.
Yeah,
but
exactly.
In reality, that's coincidental.
And here's another one that we can go over. It's x minus 1. Oh, wait, no. F of x equals x minus 1.
That's it?
No. And then over 2x plus 1.
Okay. Now, again, to me, these always make a little bit more sense if you get it in terms of y and x. So I'm just going to rewrite f of x as y. You can always do that. That's legit.
Yeah.
And now, switch the variables and solve for the new y.
So we just did the same thing that we just did, right? 2x plus.
Tell me each line.
So you multiply both sides by 2x plus 1.
You got to switch the variables.
Oh, so okay, so that would be...
When I substitute y for f of x, that's not switching the variables.
Yeah, then you do...
Sounds like it might be, but that's not it. Switching the variables is switching y and x.
So it's x equals y minus 1 over 2y plus 1.
The next line?
Then you do the multiplication of both sides, 2y plus 1, yeah.
So what's the next line?
And then after that,
you... Tell me the next line, Simon.
Oh, do you multiply both sides by 2y plus...
Tell me what the line is. Yeah, you're telling me what you're supposed to do. I want to know what the next line is.
Wait, what do you...
Sorry, I'm confused. Multiply both sides by 2y plus 1.
Oh, you want me to, like, actually tell you what to write?
That's what I want.
Okay, so it would be... What? That would be 2yx plus x.
Just want to make sure you know how to do each of these.
Yeah, sorry, I got confused a little bit.
All right. Equals what?
And then y minus 1.
Okay, and the next line?
And then you put y over on one side. You get the y's alone. So maybe move the 1 over and then move the 2yx over to the other side. So like kind of flip the 1 in the negative 1 in the 2yx.
So I get x plus 1 equals y minus 2yx. Next line?
I think it would be x plus 1 equals y y minus 2x plus plus 1.
This has to be a 1. When I factor out a y, what I'm really doing is dividing each term by y.
Yeah.
Okay?
So then that would
So
be
1.
1 minus 2x.
Yes, exactly.
Okay, so I just got those mixed up. I just got
All
them
right.
flipped around.
So what's y equal to?
And then what, you divide them, so it'd be y equals y. Oh wait, no, it'd be wait. Are we like finding the actual answer now?
We're always trying. Yes, we're always trying to solve for y. And once we solve for y, that'll be the inverse function. We're really solving for y inverse. It's just
yeah. So would it be 1 minus 2, or would it be y 1 minus 2x over x plus 1?
not quite. You got it backwards. We're solving that equation for y. How do I solve that equation for y?
You divide both sides. Would you divide both sides by x plus 1?
No. Divide both sides by 1 minus 2x.
Oh.
In other words, here's what, when you're trying to eliminate, in other words, when I'm trying to solve this equation for y, I've got a 1 minus 2x next to it. So if I want that to become y, I got to divide by 1 minus 2x. And if I divide the right side by that, I got to divide the left side by that. And now those cancel, and I'm left with y equals x plus 1 over 1 minus
2x. Okay, that makes sense.
That's actually the inverse function. So in reality, what that is f inverse of x. Since what they gave us was f of x, this is f inverse of x. And notice it's not probably that close. Let's see, x plus 1 over 1 minus 2x. A little similar. It's a little similar. You certainly can see why it might be the inverse.
Yeah.
But again, don't count on being able to recognize it, the original function. That's more coincidence than anything.
Yeah, okay.
Okay. All right. What else?
I might have to take a picture of these because these are word problems, so I'll send you a picture right now.
Okay. Then make sure you send it to David Cowan, 1949 at Gmail.
Okay, I'm gonna try and get them all in one picture. If it's too small.
Yeah, don't do that. Send one picture only, and then send the others in another one. If you try to pack too many images on one email, it'll take too long to get to me. It's like exponential. If you send one, it'll get to me in 10 seconds. If you send 5, it'll take 10 minutes.
Yeah. No, I was saying more like trying to get all of the questions in one picture.
I get you. Now I understand. Okay.
But I think it would get too small.
Do you use an iPhone, Simon?
No, I have a little Android. That's not too great.
Okay, that's what I use, is a Samsung.
Yeah, but this thing is like 5 years old. So it's not too good.
The reason I ask is because there's a particular way that you need to send pictures when you're using an Apple. With Samsung or an Android, probably works the same as mine. You just pull it up on the gallery and you share it. You send it to Gmail and type in my Gmail address.
And what's your Gmail address, David?
I'm gonna write it on the screen.
Okay.
And once you put it in there once, then the next time you go to send me something, you'll only have to type in the first 2 letters. If I'd have known how long this was going to be, I would have come up with something like XYZ or something. If I'd have known how often I was going to have to spell out my entire email address.
I mean, it's not the longest.
No, it's not the longest, but I didn't realize at the time when I chose it, because we pick our email addresses. I picked this one like 20 years ago. You don't think about that.
Yeah.
So,
Okay, I'm sending you one now. Tell me if that's too blurry.
okay. Yeah, I've got a friend who's got one, vpjoe@aol.com. That's it.
Oh yeah, that's
VP Joe. How short can you get?
that's nice and short too.
Really? Of course, he got that probably 25 years ago. I don't think you could get a short one like that now.
Anymore, yeah, because everyone just has.
Right, everything is taken. All combinations of short words. I didn't get it yet. Does your phone say sent?
Hold on. Sorry. Is there a space in your
No, no spaces.
David?
It's C-O-W-A-N.
Oh shoot! Yeah, I accidentally spelled it wrong.
That's going to be problematic because the next time you go to do it, you're going to get two choices and you're not going to know which one is spelled right.
Yeah. Gmail.com. Actually, I don't think on this phone it even saves the names, so
Oh, okay.
maybe that won't be a problem.
I guess not. Just means
It
you'll
is
have
kind
to
of
type
annoying.
out the whole thing. I'd be
Yeah.
surprised, even for a 5-year-old phone. Mine's about 5 years old. Mine does special stuff.
Okay, let me know if you get that one.
Okay. Tell me when it says sent. Otherwise, I sit here and click, 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 and it hasn't actually gone out yet. It'll say on your phone, sent, and give a time. It should.
Yeah, I don't know. This phone is kind of annoying. It like.
There it is. I got it.
Oh, you got it? Okay, sweet. And let me know if that one's too blurry, too.
Okay. I'll bring it up. You'll be able to see it.
And I'm sending you the other side.
Okay. That's what it looks like.
Oh, yeah, that's way too blurry. I think the other one I just sent you should...
The key on taking pictures that are more resolution, higher resolution, is to be very, very still when you take it.
Oh, yeah.
And have good light. Looks like you got good enough light, but it doesn't look like you were that still, or you might have your resolution set low. In other words, you might check your settings on your camera. Make sure you're on the highest resolution.
Okay, I just took another one of that side. I got it. Can you check that? I think I sent you another email. Can you check and make sure that one's good?
Yep. This looks clearer. Yeah. I can at least make this one out.
Yeah, okay.
So,
I don't know if it makes it more blurry, like in the email, or I don't know, because it looked clear on my phone.
Really? Yeah, I don't know. On mine, the only thing I've ever found that makes a difference on the blurriness is whether my hand's shaking when I take the picture.
Yeah.
And my phone actually has one where it'll take 5 pictures within like 2 seconds and then blend them together and come up with the highest resolution image, which is kind of a nice thing.
Yeah, no, that's the thing. I don't think my phone even has that.
Yeah, might not. Okay, so what are we doing, 6 or 8?
Well, I just sent you the other side way clear, so we can start at 3 too. 3, 5, 4, or 3, 5, 7. So here, let me see.
The only email that I can read is this one. This only has 2 problems on it. Oh no, looks like it has a 4 also. So I got 4, 6, and 8.
Hold on.
In other words, this image right here that we're looking at
Yeah.
is problems 4, 6, and 8.
Hold on, my phone is sending you an email right now.
Okay. You must not have ever had to send me anything before. Otherwise,
No, I
we've
think,
gone through this process. But so it's good that we're going through it,
yeah.
because eventually you're going to have to send me stuff, and got to go through the learning curve for sure.
Maybe you want to refresh? Oh, no, it still says sending. God dang it.
Yeah, that's why I say, tell me when your phone says sent. Because
Yeah.
there's no point in me refreshing constantly until yours says sent.
Well, I guess while this is sending, we should just get to work on the other side then.
All right. So, let's see. What happened to that? Down here, I guess. Which one?
Let's try and do the fourth one, the first one on the top.
Okay, number 4.
Yeah.
All right.
So we just have to write an equation. This is just stuff we're practicing in class right now.
First of all, if we look at it, we can see that as x goes up, y goes up. So, looks like as x goes up by 1, y goes up by exponentially.
Yeah.
Right offhand, I would say we're looking at an exponential curve like that.
To the fourth, right?
Well,
not to the fourth.
I don't know. Write the equation. Well, if we're looking at an exponential curve, which it appears we are,
Yeah.
the function's going to be y equals a times b to the x. And this is what we have to solve for is a and b. Well, the easiest value to look at is when you make x equals 0. Okay? Because any number to the 0 power is 1.
Yeah.
When I make x equals 0, they're telling us that y is 16, and that tells me that a is 16. So immediately I know that y equals 16 times b to the x power. Now I got to solve for b. Well, let's pick another value for x that they've given us. When x is 1, y is 64. Okay, right here. When x is 1, y is 64. So 64 equals 16 times b to the 1 power. Now divide both sides by 16 and you get b equals 4. So now we have our a and our b. And the
So it'd be
is what?
So it'd be y equals 16 times 4x.
To the x power, correct.
Yeah.
Yeah, and if if your life depended on it, you'd want to try some other values here. Like let's try an x of 2. Well, 4 squared is 16. 16 times 16 is 256.
So that'd be x to the fourth, or 4 to the fourth, right?
4 to the square.
Mm-hmm.
It's not really 4 to the fourth. It just happens to be. In other words, when x is 2, we're looking at 16 times 4 squared. 16 times 16 is 256. It also happens to be 4 to the 4th, but that's just coincidental again. In other words, that was not intended. All right, let's look at, should we look at 6, or should I check my email and see if I got...
Yeah, here, let me see if it's sent. Nope, it still says sending.
Really? Okay.
Huh.
It sounds like you are having slow internet speed, because remember it took an extra long time for your audio to come on? That usually is an indication that somebody's broadband is slow at that moment.
Yeah. And I think, I think my dad is on the internet.
Well, and plus the fact that it's taking so long to send that file with just one picture attached would also indicate slow internet speed. And that happens depending on who you have. Do you have Comcast or CenturyLink?
We have CenturyLink.
Okay.
Which sucks. I don't like CenturyLink. They're not the greatest.
They're not as fast. I've bounced back and forth between CenturyLink and Comcast for 3 years. And each one of them improves every couple of years. But at this point in time, Comcast is super fast. I know because I upload a lot of files to YouTube and I download a lot of files. So uploading is usually the slowest. And they're really fast on uploading and downloading also. But anyway, let's look at number 6 here.
Okay. So,
Okay.
Okay, so we would write this like 64.
What would the general equation be?
Would it be the same equation?
Well, I can only assume that it would. I'm not 100% sure, but I think so. In other words, it's going to be a times some b to the x. Now, what do you think b is?
I think b is
3/4.
Do you think that's 3/4?
Yeah. In other words, every time it bounces up, it only bounces up 3/4. So the function that's going to get expanded is 3/4.
The only reason
So we can now write.
But it's 3/4 every single time, right?
Correct. In other words,
so
after 1 second, it would bounce up to 3/4 its original height. After 2 seconds, it would bounce up to 9/16 its original height.
Oh, and that's why it'd be exponential.
That's why b is 3/4.
Okay, yeah, I see.
Because it's only going up 3/4 each time.
So I think the whole equation.
The only thing we have to solve for is a. In other words, they want the function, and the function has a number for a and a number for b, and has y and x as the only variables. So,
well, actually, in this case, I think x has a number too.
Yeah, it gives us a couple of numbers, but let's first of all solve for the function. In other words, we need a.
So a is 64, right?
If y is the height at any point in time, then yeah, a is going to be 64. In other words, when x is 1, first bounce, it's going to bounce up 3/4 to the 1 power times 64. So yeah, the function appears to be this.
And I think
where
the x.
X is the number of bounce. In other
And
words, if X is 1, then it's bounced this time, and it's giving you this height. If X is 2, you're going to get this height. If X is 3, you're going to get that height, and so forth.
Mm-hmm.
So it rebounds, okay, write a function that models the height of the ball over time. Well, that's it right there.
And determine
Notice that when X is 0, the height would be 64. In other words, before it's been dropped, the height is 64.
Yeah.
Okay. So then determine the height of the ball on the 4th rebound. So what's that going to be?
The what? You just exponentiate 3/4 to 4.
Correct. In other words, whatever this number is
Yeah.
going to be the answer. You care about answers here?
Well,
Yeah.
I can always do
Turn
this.
this in? Yeah, that's kind of what I'm saying is that with a lot of students, once I get it down to arithmetic, I just soon save your time and go on to the next setup problem.
Yeah, exactly.
Because it's a waste of time to do arithmetic, especially if you're going to do it on a calculator anyway.
Exactly.
And there's not much gained by us doing that. All right, how about number 8? The number of people downloading a song triples every 5 minutes. A sub 0 is the initial number of people. So she thinks the equation is A sub 1, which is the number of people that are going to download it, is equal to A sub 0 times 3 to the 5t. Can be defined to use A, oh, that's A of t, okay. After t minutes. Is Susie correct? Well, let's come up with a few scenarios. Let's assume that we've got 4 people downloading it at the first beginning. So that we know that after 5 minutes there's going to be 12. And after 10 minutes there's going to be 36. Well, let's see if this equation produces those answers.
Okay.
Okay. So if the initial people is 4, then initially that's going to be 4. Yeah. So when t is 0 minutes, 3 to the 0th is 1, so that works. Now how about when t is 1? We should get an answer of 12. We do. Oops, excuse me. When t is 1,
yeah,
we don't get an answer of 12. We get an answer of 3 to the 5th.
Yeah, times 4.
Our answer appears to be off, and it's because of that extra 5. In other words, this is really what it should be. When t is 1, you're going to have 12. When t is 2, you're going to have 9 times 4, 36. When t is 3, you're going to have 27 times 4, 108, which is another tripling. Well, hold on a second. Hold on a second. Every 5 minutes.
Easier is initial number of people.
A little tricky. This is a little tricky. That's not right either.
Well, it is saying AT, the number of people after t minutes in terms of TAO. Well, actually, no. It's asking if not explain why, or wait, is
5t is correct. 5t is correct. Let's examine it. When t is 5, no, it's t over 5. That's what it is. It's t divided by 5.
Yeah, you are right. It's every,
Yeah.
yep.
When t is 5 minutes, then this exponent's going to be 1, and we're going to have 12. When t is 10 minutes, we know there should have been 2 triplings, and we should have 36, and we do.
So she's wrong. Susie is wrong.
It's definitely wrong, and trying to figure out if there was a way to figure it out without trial and error, which is what I used. But trial and error isn't always a bad technique. In other words, sometimes it just, when you have an unusual problem that you're not used to solving and they give you an erroneous answer and you have to explain whether that's right or not, then trial and error can be useful like it was here.
Yeah, it's reliable.
Yeah, well, yeah, and you can check it pretty good. At first I thought 5t was correct, and then oh, that's not correct. And then t, I thought, well, that's not correct either. It's got to be something. There's got to be a 5 involved somewhere. And so I realized it had to be t over 5.
Yeah.
All right.
Since this email does just not want to send, I guess I could try my best to read out.
Okay. Yeah, I haven't gotten it. Go ahead and try to verbalize it.
Okay. Crap. Okay, the population of a town is tripling every 2 years. If the population was initially 4,000, write a function that describes the scenario. Use p, t, like parentheses t, for the population at time, which is t.
Okay. So the population is tripling every 2 years. And it starts at 4,000.
So,
well, we're going to use the form of the equation, the initial population times 1 plus the rate of increase to that power, where t is usually in years. So we've got to come up with an equation that looks a little bit like this. Okay, so the population would be, the initial is 4,000, and we're tripling every 2 years.
So it'd be yeah, it would be multiplied by 3, right?
Well, when t is 2, you would want this to be 3. So you'd want it to be 3 to the t divided by 2, using the same logic as the previous problem. I think that works. In other words, first of all, when t is 0, the population is 4,000. We know that. When t is 2, the population should have tripled. And it does. 4,000 times 3 to the 1 power.
Yeah.
When t is 4, population should have tripled twice. And it does. We've got 4 over 2, 3 squared is 9, it goes up to 36,000. That's tripling twice.
So that works.
Having checked 2 numbers, actually 3 numbers, I checked a t of 0, a t of 2, and a t of 4. And all of them produced what I know to be the correct answer. Now, how did we get 3? Well, r really was 2. As long as t, I don't know how we would get that. I guess we don't need 1 plus r. As long as we know triples every 2 years, then we can come up with that. That's key. And this problem's a little unusual. I don't get very many problems like this.
Well, I think technically 3 would be r, right? Oh, wait, no, never mind.
No, I think technically r would be 2. because then you'd have 1 plus 2 equals 3.
Yeah, exactly. I was thinking 3 times 1, but that's plus 1.
But these are kind of unusual problems because usually t is in years, not 2-year increments. And whenever it's doing something like that, that's a indication that you need to divide by that much. In both the last two problems, the previous problem was it was doing something every 5 minutes, and we divided by 5, and this is doing something every 2 years, so the exponent isn't going to be t, it's going to be t divided by 2.
Yeah. Which makes sense.
Yeah.
And
reading, oh, was there another part to that question?
no, that was it.
Okay.
I'm checking to see if that email is sent yet.
Here, I can take a look. No, nothing yet. And I've had other emails come in since then.
Yeah, I have no idea.
Yeah, it's tough to tell. It really is. Why don't you try verbalizing it again?
Well, this is a table. It's kind of like the one on 4.
Okay.
So on the, it's a 2 like on top of each other, and it's years over sales, right? And there's 1, 2, 3, 4, 5. So there's 5 like boxes, I guess. Yeah, like that.
Columns?
Yeah, columns.
There's 5 columns.
And then one of them is years over sales.
Labeled where? On the left?
Yeah, on the left.
Okay. Years over sales?
Yeah. Oh, I was thinking putting them in the box. No, it's years in one box on top and sales on the bottom box.
I got you now.
And then I'll read out the years ones first on top.
Okay. Go ahead.
So the years ones are 0, 1, 2, 3. So, okay, I thought you were going to put the... Sorry. On this it has the boxes, like years and sales are in a box, but it doesn't matter.
I get you now. Hold on a second. Okay.
And then on the bottom, it's 5,000, 4,000, 3,200, and the last one is 2,560.
Okay.
And basically, we have to write the equation of the function that models the data.
Okay. Well, again, this is as the years increase, the sales go down. And it doesn't look to be linear. Which,
yeah.
In other words, it would be nice to know if it's linear or not. If it's linear, the function is y equals mx plus b. But if it's exponential decay, which it appears to be, which would look something like that, then the nature of the function is different. In other words, the function's going to be a times some b to the x power. There's an exponential decay. And again, these are relatively easy to solve because we can always try 0 for x. And the moment we plug in 0 for x, we solve for a. In other words, our goal here is to solve for a and b. Well, we can easily make b to the 0 power, since that's always 1, then a is 5k.
Yeah.
So a is 5,000, and now once we have a, we've got y equals 5,000 times some b to the x. Pick another value for x, nice and easy, like 1.
Yeah.
And we know that y needs to be 4,000. So we get 4,000 whenever whenever x is 1, then we have that. And that means b is 4/5.
Okay.
And so we have our equation, we think. Let's go up and test it, make sure that it works. So
Yeah.
we've got y equals 5,000 times 4/5 to the x power. So let's see if it works for x equal 2.
Yeah.
So 5,000 times 16/25, is that 3,200? And yes, it is. 25 goes into 5,000 perfectly that many times. And that's 200 times 16 is 3,200. So again, once I've checked 3 points, and I know that 3 points all are satisfied by that equation, that's all I need. I don't need to check, make sure that when x is 3, that I get an answer of 2560. You could have a function that was like that, but it wouldn't be of the form of that kind of a function. In other words, it wouldn't take this form. You could certainly have a business where the first 2 years of sales did these numbers, and then in year 3, you only did $1,000 in sales.
Yeah.
But it wouldn't be definable by a single exponential decaying function. You would need a fairly exotic function to define that. And that doesn't go with what you're studying right now. In other words, any word problem they give you right now needs to be put into this kind of a function. The circle in the middle. And if it's decay, all that means is the number inside the parentheses is going to be less than 1. If it's growth, the number inside the parentheses is going to be greater than
1. Okay. I guess, and I'm kind of just skipping because we have a lot of short response questions. So I'm not going to try and verbalize all of those.
Okay.
But here's.
Yeah, we have 10 minutes. You tell me what you want to do in those 10 minutes.
Yeah, I have some mixed review stuff that we can go over because some of these questions look like, I don't know how to do this one, like -3 parentheses 6a net exponentiated to the -2. Wait, actually, no, it's to simplify, but I think the -2 would be in the parentheses. And then it would also be wait, hold on. In the parentheses, it would also be times b exponentiated to the -3/2, and then all of that exponentiated to the square, or squared.
Like that?
No, shoot. Hold on, let me retry this. So it'd be -3 parentheses 6a to the -squared, right? No parentheses. And then times b, and then b exponentiated to the -3/2.
And then all of that.
Yeah, all of that squared.
Okay.
Oh wait, and then over 27a minus 1. Oh wait, no, 27a to the -1 power.
Okay, there's a big difference. I was going to say, this presents extreme problems. But
and then,
as long as the a is to the -1.
Yeah, and then
here's the thing about exponents.
Wait, and then that is to the b after that times b to the 5th.
Okay. you got a number of things you can do here and a number of different ways to solve this. But the most important thing is understanding negative exponents. What does this mean? Over here on the left, 3 to the minus 2. What's that equal to?
3 to the minus 2, that's equal to 1 over 3 to the 3 squared, right?
Yeah, that's what a negative exponent means. And it doesn't have to just be in the numerator. In other words, if I had this, I could immediately take that and move it to the other side of the fraction bar. So that's equal to that. So if you're wanting to get rid of a negative exponent, just move it to the other side of the fraction bar. If there isn't a fraction bar, make one.
Mm-hmm.
Okay? So that's the secret of negative exponents. And that's the only secret. That's the only thing you need to know about what a negative exponent means.
Mm-hmm.
Now, when you have double exponentiation, that's probably the first thing we should do. This 2 applies to the 6, the A, and the B only.
Mm-hmm.
Doesn't apply to the leading minus 3, does not apply to the denominator.
Wait, I thought you multiply those exponents.
You do, but first of all, you have to know what it applies to. In other words, it does not apply to this minus 3. I'm not going to square the minus 3. That's outside the parentheses. Mm-hmm. So the only thing that the 2 applies to are those terms. So let's do those terms by multiplying the exponents, and then we'll simplify once we get that done. In other words, we're going to do this in a couple of stages. First of all, still got minus 3. Now, apply the 2 to the 6. What do you get?
2 to the 6th? What?
6 to the 2.
Oh, 6 to the 2, so that's 36.
Okay. Now apply the squaring to the A to the minus 2. What's that?
That's A to the negative 4.
And now apply it to the B.
Would that be times B to the negative 6 over 2?
Which is negative 3. Okay. And then the denominator hasn't changed.
Mm-mm.
Okay, now there's still a few ways to go, but we can do a lot with these numbers. In other words, I know the minus 3 has to be distributed to all of those terms. But I also know I can take this A to the minus 4 and put it in the denominator as an A to the plus 4. And I can do the same thing with the B. So let's do that. I like that as a first step. Still got 36. And I'm going to take the A that's down there in the denominator, I'm going to put it in the numerator. A to the plus 1. Mm-hmm. Bear with me here. This may sound overly complicated, but it's critical. There's still an A to the 5 down there. The A to the minus 4 that was in the numerator is now going to be an A to the 4th in the denominator, and the B to the minus 3 that was in the numerator is now a B to the positive 3. So the whole thing is turned into that, which is nice because we have nothing but positive exponents.
Yeah.
Now, multiply the numerators, so you have minus 108a, all divided by 27a. I'm going to combine the a to the 5th and the a to the 4th to make a to the 9th. And then I got b to the 3rd.
And you subtract the a.
Well, that's right. But first of all, let's handle the numbers, then we'll handle the a's, and then we'll handle the b's.
Okay.
The number is minus 4. 108 divided by 27, there's a minus sign in front of the 108, so the number is minus 4.
Okay.
The net a's, I could write it either like this, a to the minus 8 by subtracting the exponents, because there's a 1 there. And then I could leave the b in the denominator, but usually school systems don't want answers with negative exponents. They want all your answers to have positive exponents. So I'm going to take this a to the minus 8 and move it to the denominator as an a to the plus 8. And now I have my answer.
Okay.
That's it. In other words, I've got nothing but positive exponents, and I have everything in the right place. Now, like I said, there were 3 or 4 different ways I could have gotten to that answer. I didn't have to do it exactly this way. I could have started right out by subtracting the exponents, minus 4 minus a minus 1. It's just that I've found that when you have lots of negative signs, that's when people make mistakes. So I figured the smartest thing to do was to immediately turn everything into positive exponents and then go from there.
Yeah.
But there's no correct way. It's any way that eventually combines the A's, combines the B's, and combines the numbers and results in positive exponents. However you get there doesn't matter. Well, I shouldn't say that. You want to get there in the quickest possible way, but there's not going to be a huge difference if you take 5 steps instead of 4 steps. You don't want to take 20 steps instead of 4 steps, but usually if you just work with numbers first, the next letter next, and the next letter next, and it doesn't matter how many letters. You could have 16 letters in there. As long as you do them one at a time, it's not going to be a problem.
Okay.
Simon, I have a 4:30 I got to go to, so I'm going to let you go.
Don't want to make you late for that. Okay. Well.
Thanks. Talk to you
later.
Bye-bye.